This conference will now be recorded.
So functional interface is an interface which has one single abstract method. Means in general, in the previous interfaces, if we can see, we are having more than one method, right? So an interface can have more than one abstract methods. Abstract method is nothing but a method without body. And then in Java 8, we can have a default method and we can also have a static method. This is all about a simple interface where interface can have abstract method and any subclass can implement the interface, can override those methods and we can use it. It's
So
a simple interface
this
that
has
we are
only
using.
abstract method, Aruna?
Yeah, interface has only abstract methods.
Okay,
And
okay.
coming to default methods, static methods are allowed in Java 8. Before that, it was not there. Both the static methods and default methods that we discussed in the previous session added in Java 8,
Okay.
and all are abstract methods. And coming to today, we are going to discuss about a new interface, new type of a interface. This interface is called as functional interface. So functional interface is an interface with one single abstract method. Means if we are going to write an interface, okay, this is an interface called, interface name is calculator. Okay, and this interface can have only one operation, only one method. Return type is integer, method name is operation, and we pass two inputs. That's it. If we wanted to restrict it only for one single abstract method, then that interface is called functional interface. And what is the purpose of this functional interface? Functional interface purpose is to call the lambda expression. And now what is a lambda? Lambda is nothing but a function. For example, calculator c equal to. Now we write a function a comma b and lambda. This is nothing but a function, inline function. So here we will say a plus b. That's it. It means to perform this a plus b operation, we are implementing a function called lambda function. Lambda function, we don't need to write a function name, return keyword, begin end, not required. Now we are able to call this function by using the method which we declared in the functional interface, and we pass the inputs 5 comma 6 so that it will provide the result. So that is the result we have to print it. So system.out.println of is functional interface. So nothing but using this functional interface in combination with the lambda expression, we are able to execute our logic. So here 5 plus 6, 11. Similarly, I wanted to use the same operation, same interface, but I wanted to calculate product of two numbers. So calculator C1 equal to, now I write a lambda, so a comma b, so a comma b, and then we write a into, okay, product of two numbers. Now we are able to call that function like c1 dot op and you pass the inputs 3 comma 4. So 3 into 4, 12 you are able to perform. Means one time you are able to perform for product of the given numbers, one time with the sum of two numbers. Any logic you can implement, but same interface we are using. So this is called as functional interface. Now you are able to perform multiple implementations using lambda expression. So here you can perform some other logic also. A into A plus B into B. A square plus B square. So whatever you perform the logic, accordingly it will respond. If we don't have this lambda expression, just imagine like how we have to implement. We need to take another class, okay, called calculator IMPL class that implements calculator. We need to take another class and we need to override this method. Means we need to write a function and we have to implement the body for the function. What is the function body? Here a plus b or a into b. Let's say I will do a minus b. So return a minus b. Okay, this all implementation you need to write, whereas the same thing we are simplifying with one single line. So here is we take another class, we are overriding the method, we are implementing. Now we need to call this. So how do we call this? Right? Again, calculator C2 equal to new of calculator IMPL, means we need to create an object. Then C2 dot OP of, okay, again we have to call within system dot out dot println, and C2 dot OP of. Now here a minus b I am doing, right? So 8 comma 4. This is the way you have to use it, right? Here also you are achieving, but what is the complexity here? Complexity is you have to take a class, you have to override the function, then you are able to create an object, then you have to call it. But here you can see no need of writing a class. It's not required. Simply you write a lambda function in which you don't need to write function name. You don't need to declare the data type. You don't need to write a return keyword. You don't need to give begin and end. In a single line, we are able to achieve the same. Suppose a minus b I want to do here also. You just change it. You are able to perform a minus b here as well. So both are serving the same purpose, but in simplified implementation, right? So any logic we wanted to do, we can do with the lambda expression. Lambda is nothing but the syntax is like this: bracket, arrow greater than, and the statements in the lambda, and then semicolon. Sometimes lambda can have arguments, sometimes without argument, sometimes begin end. Suppose there are multiple statements. You can also give statement 1, statement 2, okay, statement 3. Like that you can continue. Finally, you can give bracket. But it is optional. It is a single statement, no need to give begin end. Sometimes your lambda is having some return time, right? At that time, you can also give return keyword, but it is optional. It's not mandatory. Okay, return. Sometimes you wanted to declare the data type, means here I wanted to say like int and int b. Is it required? It's not mandatory, but if you want to give, you can give. Clear? So if it is optional, why should we declare it? Not required, right? We need to simplify. So automatically it will refer to the functional interface, what data type it is declared, accordingly it will take the inputs. That is the benefit of, okay, lambda expressions along with the functional interface. Means to call this lambda expression, this interface is mandatory. For example, I'm going to comment this, right? Here I'm not using this. I can't write this lambda expression. It's mandatory to have a functional interface to refer to lambda expression. That is the purpose of functional interface. And what is the difference between an interface and a functional interface? Means in the previous example, we have seen an interface with multiple methods, default method, static method, right? If you take a functional interface, you can't write more than one function. For example, another function I have, okay, here I wanted to say square root of a given number and the input is x. If I write one more functional abstract method, everywhere you will get an error. It will not allow you to do that. So to make use of your functional interface reference to call a lambda, it should have a single function. It cannot be added with more than one abstract method. If a function, if an interface has one single abstract method, that interface is called as functional interface. Means functional interface means it is meant to call the lambda expression, to invoke lambda expression. The purpose is to invoke the lambda expression. Then what is the significance? Like this is a functional interface, right? So we need to write at functional interface. It is not mandatory, it is optional. But if you write at functional interface, so that it will not allow you to write more than one function. If you annotate like this, if you write one more function, it won't allow.
Okay.
So to restrict that, we add this annotation. Okay. Suppose if you are not writing this, it will allow to write the function. But somehow here it will give error, but it will become a normal interface. But if you want to make it as an abstract functional interface, so you should write at functional interface so that it will not allow you to add more than one function. Right?
Okay.
Now, this is the functional interface which has a single abstract method. Means only abstract should be single. But what is the other purpose of this functional interface? Can we have default method? Means let's say I have a default method called show. Okay. Yes, it allows default method. It is allowed because default method is not used to refer to lambda expression. So it can have. Can we have more than one default method? Yes, we can have no restriction. Okay. Next, can we have a static method? Yes. Static void disk, and you wanted to add something inside that. Okay, it is possible. So if it is a static method, how do we call? With the functional interface, with the interface name. Means calculator dot disk. You are able to call that. Okay. Then how do I call my show? Show can be called by creating a subclass object, and you can call that. Means like you need to create a object of, like let's say calculator IMPL, right? For example, here you created. With that, can I call? Yes. C2 dot show you are able to call. Means you are able to call the static method, default method. You are able to call static method. Okay. If required, we are able to create these two methods. But mostly functional interface means abstract method, and it is used to call our lambda expression. So that is what is explained here. What is lambda expression? Lambda expression is called through functional interface. It is an interface having exactly only one abstract method. That interface should be annotated with at functional interface to allow single abstract method. Otherwise, there is a possibility to have more than one methods in an interface.
So
And
one
any
quick question here. So
mm,
whenever we see arrow and then set of parameters arrow and
mm,
the body with single expression, that is called, we can identify that as
lambda,
lambda expression, right?
lambda expression, yes.
Okay.
This feature is there everywhere, like in JavaScript, .NET, Python, everywhere this is there.
Okay.
Okay, which simplifies writing of the function.
Mm.
Every time to just implement that, taking another class, overriding the method, it is unnecessary, right?
Mm.
It is making too many classes, too many objects, too many memory wastage. So instead of that, let us use like this in a functional way. This is
Okay.
called lambda expression.
Okay.
So if you have a simple class, so instead of using this lambda expression, if you wanted to implement this, what you have to do, you need to take a class, you have to override the method, you have to implement same like what we are using. We need to take a class, we have to override that method, means we need to redefine this method, you have to implement the logic, then you are able to use it. But this is all unnecessary creation of object. Okay, no need of creating this. So then how do we simplify that? By using this lambda expression. Whatever number of arguments are there, same thing we declare. Instead of writing a function name begin and end, we write this lambda, and whatever logic we write inside the function, we write inside the lambda. So whatever this class is serving the purpose, same purpose is served by your lambda expression in a simplest way. So that is the lambda expression purpose. It represents an instance of a functional interface. Means nothing but it is an implementation of your functional interface. Lambda expression is an anonymous block. Means a block without a name. Generally, when we write a function will always have a name and with some arguments with return type, etc. But lambda will never have a name. So it's an anonymous block. Syntax is like curly parenthesis, arrow, and then implementation. Here in the number of arguments can be 0 arguments or more number of arguments. Here statements also, there can be a single statement, a set of statements. If single statement, no begin end. If multiple statement, there should be a begin and end. And in the lambda expressions, we have the types. So what are the different types? There is a function with single argument. So single argument, you can do that. The function with two arguments. So two inputs. Function with two arguments and return type. And multiple statements. So begin end. A function without argument. A function without return type means void. A function with the input with some return type. A function with some argument with some return type. So all these possible, like when you write a function, what are all the possible ways to write a function? Everything can be done with the lambda expression. So Java Standard Edition 8 provides total 43 number of predefined functional interface. What is predefined functional interface? See, so far we are doing with custom interface, right? Means we created our own interface and we are using it here. But I wanted to write predefined functional interface. Means we don't need to write this functional interface, but still we can use lambda, what it is, right? So that is called as predefined. Predefined functional interface means, for example, first consumer interface string, okay, uh, consumer equal to, always it take a input and then it will say system.out.println of s dot to uppercase. And consumer is a predefined interface needs to be imported. So java.util.function. It's a predefined interface coming from, okay, java.util.function. What's the purpose of this consumer means? Always it take an input, but it will never return any output. It just does some logic here and display that. Then how do I execute this? So my object name is consumer dot accept is a predefined function. I have to pass, okay, my input. That's it. So that this is taking the input, supplying here and provide the result. Let us look into this. Such interfaces are called as predefined functional interfaces. See here. Whatever input we are giving, okay, it is going to perform the logic and provide the result.
Okay.
Similarly, so that's the reason for this, we don't need to write this interface. It's a calculator that we have written is a custom interface. Okay, whereas this is predefined interface, but that's serving the same purpose. It is also used to refer to lambda expression only. Suppose another consumer, what I wanted to do is consumer of integer and consumer x. I just wanted to find, okay, square of a given number. Anything I want to do with that variable, I can write the logic. And now I have to call that. Accept, give some number. So it is performing square of a given number. Whatever data type you are passing, you need to declare in the this angular braces. This is called generics declaration. It is expecting what type you are passing. Okay, that is called as predefined functional interfaces. Totally, we have more than 40 functional interfaces, but out of which a few of them we use most of our applications. For example, consumer is taking some input but never returns the value. It just prints the value. Suppose what if I wanted to use supplier, always it returns some value. Okay, sub equal to, it will never take any input, but always it returns some number. New of random dot next int. There is a function which always returns some, okay, integer value, and random, I think we need to import. Okay, so it means every time you call this function, it returns some random integer value. Okay, so what is that random integer? We have to check now. Sub is our reference name dot, what is the method we have to use? Is a get. See, for example, for consumer, accept is a method which is inbuilt. Similarly, for supplier, inbuilt method is get. Done. Now when you run it, it always returns some integer value. Suppose I run it again, it returns another integer value. Again I run, it returns some random number. Okay, when something is only returning the value but not taking any input, which is called supplier. When something which is taking always some input but it will never return a value, which is called consumer. Okay, both are like counterpart. Next is called, similarly, we have another functional interface called predicate. Predicate is used for, okay, you wanted to give some number and you wanted to calculate whether this number is even or odd. Always it returns a boolean as a result. So you're taking x, you wanted to find x percent 2 is equal to 0. It means what? If your number is divisible by 2, it should return true, otherwise false. That is the boolean condition you give. Right? Instead of writing if condition, we are using predicate. Now in this predicate, how do you test it? Right? There's a predefined function called test. And you need to give the input. Let's say 5 I am giving. If 5 is divisible by 2, it will say true, otherwise false. Now 5 is not divisible, right? So it is false. Suppose I am giving 8. 8 is divisible by 2. So it will say true. So to test such Boolean expression to return true or false, we use predicate. Okay, the purpose of each functional interface differs, right? So one is to test a Boolean expression, give true or false result. One is to check with, okay, some result type but never take any input. One is always take some input but never give the result. Okay. Similarly, I have one more functional interface predefined, that is called function. Function is predefined. So what the purpose of this function? See, here in predicate always it will return true or false only. Other than that, I can't return other types. But what if I want to do some input, some logic, and I have to get some result? So what type of input I am passing and what type of result I am getting? First one is input type, second one is output type. Now, here I am giving reference name as 1. And now I am taking some input. There is an input argument and there is also return type. So x into x means I am doing cube of a given number. And now this is going to be a function. Done. Now I have to pass my input, I should get my result. So how do I call that? So to call this interface, as usual, reference name dot apply is a function. Apply means we need to pass the input. What input I wanted to give? 9 into 9 into 9. I wanted to find cube of 9. It's not a boolean, right? It should give some result. Okay, this is output. Suppose I wanted to pass some different input and I should get some different output. Okay, write another function. So function, the input is string, but output is length of a string. Clear? So in that case, take fun one. Here x is my input. Return type is x dot length. Okay. Then I should apply fun1 dot apply. Input is string. Some input I am giving. So here I am passing input integer and I am getting the result also integer. Here I am passing string, but I am getting the result integer. However you want to design, you have to customize that. Okay.
Yeah.
It is showing now 4. Now if I add more number of characters, it is showing now 7 characters. Like that it is going to display the values. So these all comes under functional interfaces like predicate, function, consumer and supplier. So for each type of a functional interface, predefined functional interface, okay, there is a purpose. It is defined inside your java.util package. All these are functional interfaces. In which supplier we have a get method. We are able to use it as it is. Similarly, consumer is accept is a method. So we are using it. Similarly, predicate, test is a function. Return type is always boolean. And similarly, function, always apply is a function. We can pass any input and this is a return type. T is an argument that we pass. R is a return type that we get. So return type can be a string or integer or double anything. And T can be also any type. So generic type. Suppose you are passing double data type. Directly you can take double function as your functional name. For example, int function, int2 double function, double2 int function. Like that you can also declare like this. It means, for example, here you are passing integer, right? So you can take it as int function. So predefined function is there. So it is going to take an input and it is going to return the integer. So if it is an int, it cannot be parameterized with 2 arguments. If it is an int function, you don't need to give the input here. Not required. Because by default it takes integer, right? So only the return type if you can specify, it works fine. Likewise, you have the different types of functional interfaces. So int function, if you are inputting double function, if it is input type is okay float function, like that you have the different types of functions as well. So here while practicing, you can practice with this is all the functions. Suppose if you write like this, so directly you can call it same like get function. It returns some boolean value, so return function. It takes some string input and it is similar to the functions what we are writing like this. Okay, all these are the lambda functions. And there are built-in lambda functions. That's what we are practicing, right? Like a consumer, supplier, predicate, function. Okay, so the same thing is explained here.
Okay.
So the consumer function, you can accept it. Supplier function, okay, you can get it. This is a get function you have to use.
Mm-hmm.
Predicate, test, and suppose by function. By function means you are passing 2 inputs and getting final result. So it's nothing but by function means you can give more than one input. So here by function integer comma integer, there are 2 inputs and 1 output. So x comma y, and here the condition is you are writing x greater than y. If x is greater than y, you need to result return should be x, otherwise y. This is a condition you are writing, and here you make it as fun2. and by function need to be imported. Now here fun 2, you need to apply two inputs, right? 9 comma 3. So it will check 9 comma 3. If 9 is greater than 3, then returns 9. That is called by function. Okay. Suppose what if 9 comma 13, right? Then also it returns 13. Means what is the difference between a function and a by function? Function means one single input, one single output. But by function can take more than one input, means two inputs and one output. So previously when you say apply, we are passing only one input here and here. But what if I have to pass two inputs, then by function you have to use. That is the purpose of by function. And finally, method reference. Method reference means, for example, you are printing some message. If you wanted to print it, okay, you are using system.out.println. Instead of that, you can use system.out.println. For example, consumer, it is taking integer, okay, consumer 3 equal to, generally what we will do, anything if we are passing, simply we say system.out.println of x. Means I am passing some input, I have to print it. So consumer 3 dot accept and giving welcome. Welcome message I have to print by using consumer. So I am printing it. I am able to get that. But I don't want to use this lambda expression. I have to further simplify that. How do I simplify that? Okay. To simplify that, there is another way called method reference operator. System is a class. Out is a reference function. You have to use double colon symbol and you don't need to pass it. Okay, system.out.println. Now I am giving welcome 4. Right? Instead of writing this lambda expression, you can write this method reference operator. This symbol itself is called method reference. It further simplifies your lambda expression. To simplify that, we use this method reference operator. Now also the purpose is same. It is just going to display the content of particular, okay, consumer interface. So the same thing is explained here, the purpose of method reference operator. Okay, this is all about lambda expression, and as well as in combination with, if we have to use this lambda expression, we need either predefined interfaces or we need a functional custom interface. If it is a custom interface, you need to write, okay, and you have to take a reference of that custom interface. Suppose you want your conditions and your functions are limited to these operations. Take some input, okay, add some, give some result, test some boolean expression, okay, test some return time. You don't need to take this interface and write it, right? So directly you can, possible ways you can try to utilize the existing functional interfaces. If they are not possible, more customization is needed. For example, here I am passing two inputs, I am getting some result, but I have to do more number of other logics. Okay, instead of these two integers, one double, one string. In that case, you can simply design your own function in another interface, make it as a single abstract method, use that custom functional interface for your implementation. Okay, this is the newly added feature in Java 8, which is called functional interface and lambda expression, that simplifies your object orientation. Means you don't need to every time override the function, write a separate class, not required, right? You can directly use it. So that is what is the purpose of lambda expression and functional interface. Is that clear, Shamla?
Yes, Aruna. So this is available in 11 too, right?
Yeah,
Not
yeah. This is 8 above
8
any Java
onwards.
version we
Yeah,
can use.
yeah, yeah. So from 8, it is all lambda expression, right?
Yes,
Okay.
yes, yes. So most of the time we try to simplify, not writing unnecessary number of classes, overriding the function, not
Mm.
required. Just go with this syntax. Okay.
Oh, yeah.
And this thing I will upload into GitHub.
Mm-hmm. Sure. Yeah, you are uploading both the code as well as
Ah,
the
yeah.
PDF, right?
Yes, yes, Shyam.
Yeah, sure.
And also code. So predefined functional interface and user defined functional interface. Everything is uploaded in the same file.
Okay, yeah.
Okay, you will find the PDF and as well as
Okay,
functional interface demo.
sure.
In the next session, actually, Stream API is another important concept in Java 8
Uh-huh.
that we will discuss in the next session because it has many features. So
Okay,
it will take more time. So we cannot finish now. So
okay,
we'll
okay,
continue in the next session with Stream API. But to
okay,
practice with Stream API, thorough practice is needed for Lambda expressions.
okay.
Okay, you
Mm.
can just have a look and execute them. We
Okay,
can continue Stream API in the next session. Okay.
okay, sure, Anna. And Anna, I'll be joining class again on Monday.
Okay. Okay, Shamla. Sure.
Okay, so I'll let Prakash Garu also know. Okay,
Okay, sure.
okay. Thank you so much and
Okay.
have a wonderful day. Thanks a lot.
Yeah. Bye.
Bye.